In this problem, we're given a system of equations, and we are to use our graphing calculator to find its solution. The first thing we need to do is to take this system and form what's called an augmented matrix, for which we just look at the coefficients on the variables, such as 2, -4, and +1, and the constant on the right-hand side of the equal sign is 13. We'll write that down. This first row in my augmented matrix represents this first equation. We typically separate the coefficients on the variables and the constant with a vertical line. In my second equation, my coefficients on my variables are -1, +1, -1, and the constant is -4. We'll put that right here. My third row will be +1, -2, and since there's no variable z here, its coefficient must be 0. You could think of this as plus 0z, because 0 times z would be 0. So if any of your variables were missing, if you will, in any of the equations, we could think of the coefficient as 0. Don't forget that the 7 is the constant. It'll go right here. This is the augmented matrix that represents the system. Notice that it has 3 rows because we had 3 equations. It also has 4 columns. Columns go up and down. 1, 2, 3, 4. This is what's called a 3 by 4 matrix, and the size of the matrix is often written down here, and you'll need to know this to type it into the calculator. Let's go to the calculator. The first thing we need to do is to define this augmented matrix in your calculator. Press the second key, then the button that has matrix as its second function. Right arrow over twice to edit. Press enter. This is where we tell the calculator the size of our matrix. Remember, we had 3 equations, so that formed 3 rows. And our augmented matrix had 4 columns. So press 4, press enter, and now we will have 12 places for us to type the numbers in. You can simply just press the number 2, enter. It will pop to the next entry and continue typing. When you're done typing in all 12 entries, double check that you typed it in correctly. Now that I've defined my matrix and called it matrix A, I'm going to go to my home screen by hitting second, quit. I now need a command on the calculator called RREF, which stands for row reduce echelon form, after which I will tell the calculator which matrix I want to row reduce. Since we put our matrix in matrix A in our calculator, we'll have to tell the calculator that that's the matrix we want to row reduce. Let's take a look at how that's done. Let me go back to the calculator. This is the second time we go back to our matrix. It's important that you hit second quit and go back to the home screen though, as that's where we want this command written. So I'm going to go back to the matrix menu, second matrix. I'm going to go over 1 to the math submenu. Hit the down button several times until you see the command RREF. REF stands for row echelon form. We want row reduced echelon form so we can get the solutions to the system. Make sure you have RREF selected, press enter. Now we need to tell the calculator which matrix we stored our numbers into. So I'm going to go back to the matrix menu a third and last time, second. The button that has matrix as the second feature. I'll select the first one because that's the matrix in question. If you stored your matrix in any other letter, of course you'd have to go down. Press enter. Now I have the command row reduce echelon form matrix A. If you like, you can put a right parenthesis to cap off this left parenthesis. Press enter. Now we have to go backwards and read the augmented matrix and transform it into a system of equations. Here's a snapshot of what the calculator returned. So the calculator did a lot of work for us to row reduce this matrix and put it in what's called row reduce echelon form to give us 1, 0, 0, 3. The calculator does not draw the vertical bar that you could think of taking the place of the equal sign in the equations. Now going backwards, thinking of these are my coefficients on x, these are my coefficients on y, and these are the coefficients on z. Reading each row as an equation, this says that 1 times x plus 0 times y plus 0 times z is equal to, again thinking of the vertical bar as being equivalent to the equal symbols, it's equal to 3. Notice that 0y and 0z need not be written, and we tend not to write the 1 in front of the x. So this really says that x is equal to 3. Now we need to find out what y and z are to get our ordered triplet solution. The second row will tell me the value of y. It says 0 times x plus 1 times y plus 0 times z is equal to negative 2. And if you simplify the left-hand side, you notice this basically says that y is equal to negative 2. My last equation you probably get without writing this down that z is equal to negative 1. But if you want, this says 0 times x plus 0 times y plus 1 times z equals negative 1. Simplifying, this equation says that z is equal to negative 1. Now that I have my solution, you could check your solution by plugging each of those three numbers into each of the three equations and make sure that you get true statements in all three cases. Because my numbers came out integer values, this is very easily done without a calculator. But if you'd like, going back to the calculator, here's a way to have your calculator do the arithmetic for you. I can clear the screen. What I can do is press 3, the store key, the letter X, press enter. Type negative 2, store. To get the letter Y, I press the alpha key and the number 1. To store negative 1 into Z, I type negative 1, store. Alpha 2 will give me the character Z. Now I can simply type out each equation, 2x, subtract 4y, plus Z, press enter. For those three values of x, y, and z, the first equation comes out to be 13. So basically this equation says 13 equals 13, which is a true statement for that ordered triplet. Do this for the next two equations to verify that the second and third equation are satisfied with that ordered triplet. For example, negative x plus y, subtract z. Make sure you don't use the negative key. Make sure you use the subtract key when you type subtract z. That equation comes out to be negative 4, as expected. Finally, x, subtract 2y. Press enter to see that the third equation is equal to 7 for those values of x, y, and z. This proves that this ordered triplet is indeed the unique solution to this system of equations.